In this video, we're going to discuss how to predict products for synthesis and decomposition reactions. But first, we must review our diatomic elements. As you recall, back in the last unit, we discussed very briefly that diatomic elements are elements which cannot exist as a singular atom. There are 7 of those elements. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There are a couple of mnemonic devices you can use to help you to remember. The first one is go to 7. That means go to element number 7, which is nitrogen. So we go here to nitrogen. And then make a 7. You can see we make a 7 here with those elements. And then hydrogen is our 7th one. That's why the phrase there are 7. Two other mnemonic devices you can use are Brinehoff, where you get your Br for bromine, I for iodine, N for nitrogen, chlorine, hydrogen, oxygen, and fluorine. Or if you like statements, you can use I have no bright or clever friends. So you get iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. All right, so remember we talked before that a synthesis reaction occurs when 2 or more reactants combine to form a single product. The basic reaction type or expression is A plus B makes AB. Now, of course, the thing to remember, when we make the compounds, we still have to use charges to write the formulas correctly. So in this example of a synthesis reaction where we have sodium and chlorine reacting to form sodium chloride, you see we have sodium here plus chlorine, which is a diatomic element, which is why there's a subscript 2. They come together to form sodium chloride. Now, with sodium chloride is NaCl because Na is +1 and chloride is -1. And so we have 1 of each. Okay. Also, for this reaction, we must balance it, right? So remember, to balance the reactions, we use coefficients, right? We have 1 sodium here and 1 over here. But here we have 2 chlorines and only 1 there. So we would need to put a 2 in front of the sodium chloride to make that a balance for chlorine. But now that unbalances our sodium, so we would have to multiply by 2 over here for the sodium. And now we have a balanced synthesis equation. All right, so let's look at some examples. So this first one, we have lithium plus sulfur, right? When those 2 combine, we're going to get lithium sulfide. And so to write the formula for lithium sulfide, we have lithium and we have sulfur. We need to think about what are the charges. Since lithium's in group 1, it has that charge of +1. And since sulfur's in group 6, remember those all have a charge of -2. Now, of course, this has to add up to 0, so we're going to have to multiply our lithium by 2. And so we get the formula Li2S. Then, of course, the reaction must be balanced. Since we have 1 lithium on the left and 2 on the right, that means we then need to multiply our lithium by 2 so that we can get 2 lithiums. And then we have 1 sulfur, and now this reaction is balanced. Let's look at the next one. Calcium plus nitrogen are going to form calcium nitride, right? So we're going to have our calcium and our nitrogen. And of course, we have to think about their charges. The calcium's in group 2, so it's a +2. Nitrogen's in group 5. Remember, that's a -3. Those must add up to equal to 0. Since they do not, right, we have to make them equal to 6, so they'll be added to 0, right? So I multiply calcium by 3 and nitrogen by 2, and we get Ca3 and 2. And then, of course, we must balance. So we have the 1 calcium here on the left and 3 calciums on the right. So if we multiply our calcium by 3, now it's balanced. And then our nitrogen, we have 2. Over here we have 2, and that's balanced. Our third example is aluminum reacts with sulfur. In aluminum reacting with sulfur, we get aluminum sulfide. So again, that's aluminum, Al, and S. And then we have to again think about their charges. Aluminum is in group 3, so it's +3. Sulfur is in that group 6, and so it's -2. Again, those do not add to 0. Again, that's that 3-2 combination. So we're going to multiply by 2 and multiply by 3, and we get the formula Al2S3. And then finally, we must balance. We have 1 aluminum on the left, 2 aluminums on the right, so we must multiply aluminum by 2. And then we have 1 sulfur on the left and 3 sulfur on the right, so we must multiply sulfur by 3. And then this reaction is balanced. We will practice this more in class tomorrow. Decomposition reactions are the other reaction we're going to talk about predicting products for. A decomposition reaction, if you recall, occurs when one reactant breaks down into 2 or more products. It can be represented by the general equation of A plus AB yields A plus B. Again, it's breaking down. Again, this is the opposite of synthesis. An example of a decomposition reaction is water breaking down to produce hydrogen and oxygen gases. We can see here that we have water, and it breaks down into hydrogen and oxygen. Now our hydrogen and oxygen have the subscripts too, because they are part of our diatomic elements. Let's look at some practice problems. So number 1, zinc oxide. Zinc oxide is going to break down into zinc and oxygen. Anytime from here on, when we have a singular element, we have to ask ourselves the question, is it diatomic? Right? Is it diatomic? So, is zinc part of our 7 diatomic elements? No. Is oxygen? Yes. So since oxygen is one of our diatomic elements, it has to have a subscript too. Then, of course, we must balance our reaction. Our zinc, we have 1 on the left, 1 on the right, so it's balanced. However, our oxygen, we have 1 on the left and 2 on the right, so we must multiply our zinc oxide by 2. Now that unbalances our zinc, so here in front of zinc, we must multiply by 2. Now our reaction is balanced. Number 2, lithium nitride. It's going to break it down into lithium and nitrogen. We must again ask ourselves the question, is it diatomic? Is lithium part of our 7 diatomic elements? No, it is not. So it would not have a subscript. Nitrogen, is it one of our diatomic elements? Yes, it is. So we have to give it a subscript too. All right, now we can balance. We have 3 lithiums on the left and 1 lithium on the right. So we can multiply our lithium on the right by 3. Then our nitrogen, we have 1 on the left. Oh, but we have 2 on the right. So we'd have to multiply our lithium nitride by 2. But now that changes our lithium nitride, right? It changes our lithium. We now have 6 lithium. So I have to erase that. And then now I have to put a 6 in front of my lithium to make that balance. Okay. All right, the third example, magnesium chloride. Magnesium chloride is going to decompose into magnesium and chlorine. When we have our singular elements, we must ask ourselves, is it diatomic? Is magnesium one of our 7 diatomic elements? No, it's not. Is chlorine? Yes. So we put our subscript 2. And then we have to balance. We have 1 magnesium on the left, 1 magnesium on the right. That's balanced. 2 chlorines on the left, 2 chlorines on the right. That's balanced. We now have a balanced equation. These are our decomposition reactions. Again, we're going to practice this more in class tomorrow.